Okay, here we're adding and subtracting fractions. Now listen closely. When we add and subtract fractions, you guys know you have to find a common denominator before you start adding fractions together. So let me give you guys a non-polynomial fraction example. Let's say we had 5 over 6, and we had 5 over 24, and we had 1/2. And we wanted to add all these together. You guys are, I'm assuming, pretty good at this. You would say, oh, 6, 24, and 2, they all go into 24. And then you would just make them all 24, and then you would add them together. Yes?
Yeah.
Yes. You would multiply this 6 by 4, and then multiply top by 4, right? And then this one you would multiply by 12, you multiply top by 12. That's great. Now I'm going to use the same concept, except I'm going to throw in this new word, factors. We're going to use factors in order to find common denominators here. So here, let me show you. We got 5 over 2 times 3. Now that's the same as 6, right? Right. Okay. Then we have this 24. How do I write the 24 into factors? Let's do a factor tree. 24. What times what gives me 24? 4 times 6. And then I break apart the 4 to 2 times 2. I break apart the 6 to 2 times 3. Wow. So this 24 factors into 2 times 2 times 2 times 3. Kind of disgusting. I'm going to write all the 2's out just because it makes it easier to explain. 24's prime factorization looks like this. Now, what about the 2? Can I factor that 2? You guys are all sitting there going, I like the old way. All right, so I'm using factors. Now, the way you do common denominators with factors is you ask yourself this question. What factors are they missing? Now, I can't cross factors out. I can't do that. But I can multiply the top and the bottom by a new factor. So what would I have to multiply 2 and 3 by so that it equals 2 times 2 times 2 times 3?
2 times 4.
Just 2 2's, right? Yeah. Whatever you do to the bottom, you do to the top, right? So now these two fractions have common denominators. What about this one right here? What's this one missing? A lot more. 2 times 2, and then also a 3, right? Right. So I go 2, 2, 3. Now I can clean it up. I can multiply the top, I can multiply the bottom, and I would have common denominators. I would be at 24. What is 2 times 2? 4 times 2 is 8. 8 times 3 is 24. So they would all have 24, and then you would do your thing. And you guys remember when you guys do your thing. All right, let's just finish it just because we can. Okay, that would be 20 over 24 minus 5 over 24 plus 12 over 24. You do not touch the denominators, right? You just add the numerators together. And so we got 20, and I'm going to make this add and make that a negative 5. So what's 20 plus negative 5? That would be 15, and then 15 plus 12, that's going to be 27 over 24, and we're just going to leave it like that. So let's apply this factor business over to this guy right here. Let me clean it up. So let's attack this the same way. Can we factor all these denominators? This first denominator is not factorable. Neither is the second denominator. What about this last denominator? That one is factorable. Now, when you guys write this new line out, make sure you give yourselves lots of space. Okay, so I'm going to write this out. Okay, I got to factor this. This is called a difference of squares. How do I know this? Because there's a minus sign right there, and that's a perfect square, and 1 is a perfect square. So because that's a difference of squares, what I can do is I can write 2 factors right here, and I get x plus 1 and then x minus 1. All right, so everything is factored. Now, what's my common denominator? This one has an x plus 1 and an x minus 1. This one has just an x minus 1. What does this one need to look like that one? An x plus 1. So I'm going to put an x plus 1 right here. So now he kind of looks like that last one. Actually, he looks exactly like that. This denominator is now common with this denominator. But what about this one? There's no x over here. So what do I have to do to this one so that it has one of those? Yeah, you have to put another x in there. Whoa. But now, can I make all of these other denominators look like this one? Yes, I can. What do I have to multiply to this x to make him look like this one? X plus 1 and an x minus 1. And make sure you do the same thing to the top. Whatever you do to the bottom, you must do to the top. Okay, and then what do I have to multiply this last one by? Just an x. All right, so now do I have common denominators? Yes. Now in order to do our next step, which is keep the denominators the same, and then add the numerators together, I had to simplify our numerators. So let's simplify our numerators. And I'm going to try to write less. I'm not going to rewrite everything. What is this, guys, simplified? Let's see. 3 times x is 3x. 3x times x is going to be 3x squared. And then 3x times 1 is going to be 3x. Okay, so I did a lot of that in my head. All I did was I multiplied the x and the 3 together first, and then I distributed it to both the x and the 1. All right, so that guy is simplified. Let's simplify this guy right here. Oh, yuck. Oh, snap. We know what these multiplied together give us. Do you guys remember? It's right there. X squared minus 1. So x squared minus 1 minus 1, or minus 1. And I have to multiply this by 2, right? So let's make this a 2 right there and this a 2. All right, that one's simplified. All right, this one right here. I get x squared plus 3x. That's just a simple distribution problem. That one's done. Oh, snappity waggity daggity. All right, should we clean this up, or are you guys good right now? Clean it up? Okay, I'll clean it up. All right, we got 3x squared plus 3x over x times x plus 1. Notice I'm not distributing the bottom yet. I'm keeping it in factored form, and there's a reason for that. X and then x plus 1, x minus 1, and I get 2x squared minus 2 plus x squared. You guys want to know a good trick when you guys are doing rational expressions? Always, always, always make sure that if you see addition or subtraction, you guys put parentheses around it. So parentheses, parentheses, and then parentheses. The reason why you want that is because of that. You guys see that negative right there? If you didn't have parentheses around these dudes, you might not distribute this negative. If I slash and dash this doggy, it would look like so. And then you have to distribute that negative. So you get negative 2x and then positive 2. You guys got that? Yeah. Now the parentheses on top don't really matter anymore because I don't have any more distribution to do. How many x squareds do I have up here? I have 3x squared, negative 2x squared, and then 1x squared. So how many x squared is that? That is 2x squared. Because 3 and 1 is 4 minus 2 is 2. Now the next term is going to be the x term. I have a 3x term. Let's cross those out, yeah? Yeah. Cross them out, cross them out, cross them out. All right, now I have an x term right here, x term right here. Wait, there should be an x term right there. Yes. I did not distribute the x to the 3. You guys didn't catch my mistake. You guys are not paying attention.
You said it out loud.
Liar, you did not say it out loud. I'm recording this, so I'll check. I'll see what you said. Okay, so we have 2 x terms. We have a 3x right here and a 3x right here, which is 6x. And then we have the constant term just chilling. And on the bottom we have x. I'm still not going to multiply it out. X plus 1 and then x minus 1. All right. The reason why I waited to the end to possibly distribute this is because I need to see if I can simplify this nasty fraction. Can I take anything out of all these terms? I could take a 2 out, and then I would get x squared plus 3x plus 1. Okay, can I factor this trinomial? Oh, I love that there's a positive 1 right here. That means I just have to find 2 numbers that multiply to give me 1 and then add to give me 3. Impossible. So that's our answer. Do I have to multiply the factors back out? Well, you can, but it's unnecessary.